Welcome back, dear friends, to a very exciting episode because the head, for the first time, the whole head shell has finally finished printing. Clear the decks, you say? Oh, I don't know about that. Here she is. So 15.5 hours that took to finally print, but it did it, and that's very exciting because I've also managed to print eyes. Oh, I started off thinking, I know, I'll be clever. Let's print two eyes at the same time. Yes. Perhaps I'll put them too close, but obviously you can see as they're stringing across, they're so fine. I had a little bit of spaghetti there, so that was out. So I've printed both of them individually and a new one of those, a combined thing, to hold the eyes in place. I've got the mouth parts left over, you know, the ones I developed. They're ready to go from that one, as is the eye motor. So it's time to put everything together. Thing is though, I haven't been working for about 25 hours or something, because I just haven't stopped printing with it. It's stopped printing. We can't have that. But what can we print now? Well, we've got all these bits printed. But the hair. So what I've done is to save that as an STL and then put it into the Creality slicing software to discover to my horror. Oh, hurdy, hurdy, hur. 25 hours, 5 minutes, 62 metres. That's nuts. That can't be right. I mean, it said it was going to take 12 hours for the head, and it took 15.5. Thing is, if I start this printing, I can't actually, and then find I need to make changes while I'm putting the head together, I can't do anything about it. I think I'm going to have to wait. I haven't got around to buying another one yet. But that's nuts. Heavens to Betsy. 31 hours, or more like 38 hours at this rate. That's nuts. Oh well, I've put that out of my mind entirely. Let's see if... I'm hoping this next part of the assembly is going to be most rewarding and enjoyable. Although, having said that, I do wonder, because the fiddliness of the eye... Oh, I've just realised two things I haven't printed yet. Eyeballs. Right. Well, that's good. I'll get that switched back on again and warmed up, and we'll get them printed. Well, I've cleaned it all up, all little bits and pieces with some nice new sharp scalpel blades, and inevitably cut my finger. Never mind. This is going well. What I've discovered, I'm relearning stuff. Let me zoom in a little bit. Because the eyes, I suppose I could change the shape of the back of the eyeball, because they're sort of sockets and come round quite a lot. You can't glue these together and fit them in together. You have to sort of pop them in, but once they are popped in, because the gear teeth will line up, I'm wondering whether that's just as good to do it like that. Because there's one gear that's going to be turning both of them. Who knew? So that's exciting. Good start. While I'm waiting for the eyeball to print, I might as well take the motor off this bit and transfer it into this bit. It's so different to work. You know, it's so easy when you've got two halves. Very difficult when you've got one hole, not one half. I was also very pleased to find that the brass rod I was trying to poke through the neck hole, pivot hole, was 3.3 millimeters, which is some inch fraction, not 3, but I found I had got 3 without any drilling. Oh, look, a swingy thing. So that's nice. Right, let's get taking the old one to pieces. And in the blink of an eye, just as I'd finished speaking, the eye finished printing. I haven't printed these bits separately, although I'm amazed because I left a 0.2 millimeter gap. I can actually see the gap round it. I just wanted to check for the time being that the overall dome would actually fit within, and that funny little bit down here would fit. That took me so long to design. I've got the eye screwed in, the eyeball from the back, and it does fit fairly nicely, although you can clearly see there's a line because this part of the eye was printed upside down. It's not perfect, so you can see a line there, which is a bit annoying. I'll try and get the eyelid in. It works in principle. That is opening as far as I'd design dictating before it hits on the back of that eye support. But you look in the corner of the eye, there's a big gap, and I'm just not happy with that. I have a couple of choices. Either I can go back to an eyeball, which I'll put back on, which hasn't got that bottom bit on, because I think that just is, with the gap round it, it's just all a little bit much, really. I think it, or, I mean, the fallback plan, which I've always had all along, is to not have the eyeball separate, but to do it like a doll, a child's doll, where the eyelid opens, like the first one I made. The eyeball is fixed, so as she opens her eyes, the eye comes up into view. That would solve the problem, because that gap between this and that is much, much smaller. I'll have a think. Anyway, it's that time again to take the dog out. Heavens to Betsy. This is why these videos are taking more and more time to produce, because I'm having to work at the minutiae, I think. That's right, adding the eyelid to the eyeball. And then I was working on the fact that I wanted, because I didn't want a big gap round here, if the eyelid was still a millimetre larger diameter and this was a millimetre smaller, you would get a gap, which the whole point was to avoid. So I worked out how I could squash the actual eyeball a bit, keep it the same width and the same depth, but squash it down a bit. That way, dear friends, rather cunning plan, even though I say so myself, you get an eyelid like that, but the back of it is still completely the larger diameter. Having printed the eyelid successfully, been thinking, well, that's so fine, surely it can cope with this little bit here. So I tried printing it at the standard 0.1 for normal quality. As you can see down here, it's really rough. It couldn't cope. So I thought, okay, fair enough. Let's try it at 0.06. There's 0.06, same problem exactly. Because I sliced the back of it off, and it printed beautifully at 0.1, sort of standard or whatever. So that's nice, but obviously it couldn't print that at the same time. So what I had to do was to separate the two, like this. And I made a key shape on it. So that's got a little block on the side, so it slots in. And here indeed I am printing two more eyes and two more gears, just to check that everything will actually fit together. Talking of everything not fitting together, I just thought, while I'm waiting for those eyes to print, I could assemble the mouth, because I printed a new one of these. Well, the other one got stuck. I couldn't actually get it out of that head, half head. So I printed one and just discovered it doesn't fit. It's too wide. This head is too narrow. And I thought, ooh, I haven't tried that on the neck yet. Try it on the neck and it doesn't fit. It's too narrow. So that's interesting. I know that I must have made a mistake when I was working with half a head. So I've got to do some design changes. I think it only means I'm going to have to reduce the width of that slightly. That's okay. And reduce the width of that. That is far more preferable than having to change all this. Although I have to at some stage, because I don't need those eyeball supports anymore. Thing is, of course, I couldn't print this attached to it, so I had to cut it, slice it apart, and then make a little socket in here. Originally it was just a round one, so you had no idea where you should glue the gear in, where it should line up with. And I thought, no. So I created a key, funny little rectangular bit at the bottom. It slots in beautiful and allows you to line it up perfectly, and also allows you to use these for both eyes and just flip the actual eye bit over. So that's exciting. And I've tried some other things afterwards, just to overcomplicate matters further, of course. But we're going to stick with that. The eye saga continues. It's unbelievable. I printed them as a final test and forgotten that I'd added at some stage, made that rim a teensy little bit wider by about 0.2 millimetres to try and take up any horizontal slop, and they wouldn't fit. So then I removed that and made it back to where it originally was when it did fit, and then printed another couple and forgot to flip one over. He could not make it up. Useless. So Last night I printed another two and I have put them in, and I managed to remember to flip them over, and they are really nice and loose. What I'll do now is to get the motor in and see whether we can actually get them opening and closing. I don't want to say too much, but I'm starting to begin to hate this project. Oh, it's just so complicated and involved. Because having got those two eyes printed, I couldn't get them to line up, both sides. And then I noticed that in fact I'd flipped the eyeballs over, but I didn't think I had to with the gears, but the teeth are ever slightly out by a few degrees, so I had to then flip that over. So I'm printing another one of them, and I started making cutting those little bits, the pivots for the jaw, got the jaw in and all working, and then noticed the wire had snapped on the mouth solenoid. So I had to take that all apart, this out again, thank goodness I can get it all out, it's good. Then I solder that and then put it all back together. Oh, it's just never ending, it seems. Just want to get the eyes and the mouth to work. Oh. Well, that was a little bit more positive, because I used to remember to put the spring and the solenoid centre in first. Well, almost, before I screwed that on. I also found out how to set this up and to align those two little rods. Bit of masking tape over the bottom holds it all on, and it makes it so much easier. So that's good. I just need to wait for this wretched eye, to finish printing so I can try and realign those ones. Oh, the neck. I remember thinking it can't be this simple getting a servo motor to move it like that, and it was. I should have known that didn't bode well for the future. Anyway, while I'm waiting for that, I'll go and do the dishwasher. And then he managed to achieve something, dear friends. If I can get the right wires, we can. Eye open. Isn't that lovely? I'm so pleased about that. God. I'm really looking forward to writing a little sketch thing to function to do that. And then the mouth. Oh. And of course I can control the speed and everything with both of those, with the pulse width modulated output to control the power, sort of. Oh, that's amazing. And then being able to look right and left. Oh, so excellent. And it's amazing how lifelike she looks suddenly, with her eyes and everything. Now I can try and sort out that wire bending bit that links the servo motor in the head with the back of the neck. So here are the link juice from before, and here are my drawings. See if we can get that set up and get the servo screwed in. Oh dear friends, another step closer. Oh, I'm so pleased to have got that linkage worked out earlier. That's really handy, and it just fitted in so I can get the dimensions off that, and that's allowing her to look right up and right down the limits of the head without having to stop the servo or anything. I've got the wires fed up and around, because it's one of those things I don't want to get them in the way of any of the internal mechanisms, so I've worked out where I need to add a couple of little bits, little sort of hook things. Oh, that's great. Right then. So I think I'm going to try and dig around and look for a couple of H-bridges so that I can then control the solenoid and the eyes from the output of an Arduino, and then possibly even get it wired up to an Arduino. I can't wait. What on earth is this new noise in the workshop? Well, I really wanted to finish this video by showing you something working, showing her face moving. So I've been wiring things up, and indeed programming an Arduino sketch, and indeed connecting an Arduino. That is doing my head in a moment. So we've got an Arduino wired up. I've written a sketch just to basically test, and also I miss writing sketches. I've really had enough fiddling around with the 3D printer. So I've written a sketch just to move her head around, open her eyes, and so we can see what it looks like. Eventually, next video, I want to replace that with a Teensy and a Teensy audio board, because they're amazing and it'll allow her to speak and to control her mouth properly. So I've got that. I've got outputs to the two servo motors, pulse width modulated output, so I can move her head up, down, left, right. And they are run off because obviously they draw far more current than the Arduino can provide. I'm running them off after several hours of mistakes and trying to work out what on earth I was doing. The 5-volt output of one of these H-bridge controllers, because you run it from 12 volts, not 5 volts. You run it from 12 volts, then there's a voltage regulator on board which creates the 5 volts logic for the chip, but doesn't run the motors. The 12 volts runs the motors, but then you can take that down to, with a pulse width modulation to sort of 5 volts, by putting in 105, I think I calculated it out of 255 full cycle thing. So that's nice, and then you can also use the 5 volts that this has produced, that's what I started with actually, to run the two servo motors. Great stuff. The thing is, the noise, and I've just written, for the time being, I've written a sketch which just has lots of random things. This is the loop, I think, yeah. So it's just opening and closing the mouth randomly using milliseconds for timers. I know I'm using them the wrong way, but I'll correct the maths. I can never remember once I've got it working. As I say, this is temporary because I just want to see it working. So it waits and then opens the mouth and then waits and then closes the mouth and so on and so forth. Thing is, because I've now got this controlled with pulse width modulated output to get the right voltage, the windings on the solenoid are buzzing. I will illustrate for you. If I plug this back in, this is the 12 volt supply. I'm running the Arduino off the 5 volts from the computer. Right. So the sketch is working. That is not good. Also, she's blinking, and that's fine because the motor, for some reason, the windings don't vibrate. So the trick is to change the frequency, to raise the frequency of the Arduino's pulse width modulated output with some special code. I was so thrilled when I discovered how that you could do that, because I had exactly the same problem with the barometric prognosticator 1, where I had a little solenoid swinging waves backwards and forwards from side to side, and it was every time it kicked in, every 5 seconds or so, you'd have this huge buzz. Right, I will go and look that up for you. Well, for me actually. What a joy. I've just looked up and found the sketch for that, and there we have the line of code that changes it. You type that in setup, and then it says set pulse width modulator timer 2, that's pins 10 and 9. Actually, this might not be because I think this was for the Mega, but we'll give it a go. She's now whistling, a whistling automaton, but everything's working, so I need to up the stakes again and try it on 31 kilohertz. Let's give that a go. Thank goodness for that, 31 kilohertz. I did read that this particular timer affects the servo library which I'm using, so I'm now going to try the servos again to see whether they still work. Well, they were absolutely right. The servo, when you add the servo library to control the servo motors, it just stops my changes and the eyes and the mouth don't work at all. Nothing. Not a sausage. I just wanted to set it up so I could get a short video. We were all involved in all these PWM timers and all that. So I've now gone back and just resorted to a wonderful TIP 2121 Darlington pair just to work the mouth solenoid. And there it is. Just so simple. Because what I realised was, can't help explaining things, when I was running this off 5 volts, which I am again, there was too much of a voltage drop across the switches to work the solenoid that needed sort of half an amp. So that's now running for 5 volts, that's doing the eyes, and the Arduino is just controlling the Darlington pair to switch 5 volts straight to the solenoid with a cheeky little diode to stop any back EMF across it. Which means it doesn't hum anymore, and it works at last. Thanks very much for watching. I think this is a good place to stop. Next time, getting into teensies and audio and all sorts of other exciting things. Brilliant. Thanks again for watching.